Good afternoon, everyone.
Good
Afternoon.
afternoon.
Yeah, good afternoon, sir.
Good afternoon.
Um, Today we are going to discuss one of the most important topics that you could ever consider in this series, cleaning. Is Professor Charles here?
Yeah, right here.
All right. Arguably is one of the most important topics. So please pay attention, and it's also quite loaded. Someone was at least I think that was the day before yesterday. Someone was texting me that it was quite loaded, and even this morning, someone also texted the same thing. It's been loaded for a reason because the job that you are going to do revolves around cleaning and sterilization, and for that matter, you need to get the complete information. So, Professor Charles, if you are ready, please, the floor is yours.
Sure. Welcome everyone. As it said, this is going to be, it's loaded for sure, but it doesn't mean it's not going to be able to be finished. We are surely going to finish it. Okay, it's loaded. That is what we should put in our minds. Since it's loaded, we're going to be loaded today, but we are going to be loaded for a good cause. Okay. All right. But before we go into that, I think the last time I met with you guys, we spoke about the principles of asepsis, where we spoke about medical asepsis, surgical asepsis, which we're not going to actually waste too much time on it today because we already said we are loaded for today's work. But those are certain things that you always have to remember. And then the environmental, managing the environment, where we said that you have to maintain that environmental integrity. It's serious. Take that into consideration every time that you are doing decon, okay? So we're going into our cleaning today, all right? Prof, I think, Director, I think I need the slide. You have the surgical instrumentation on there. So we're supposed to have the cleaning. All right, so guys, our introduction, I think cleaning, everybody knows cleaning. I don't have to waste time on cleaning now. But definitely, we may ask somebody to tell. Can anyone tell us what cleaning, just in simple terms, what is cleaning?
Basically to make something look neat.
To make it look neat. That's a good one. Yes, make it look neat. All righty. Which you see the keyword, the look, which means our eyes are going to see it clean, right? Neat. Good, which is good. But then we'll get into the details to see if our eyes only can determine whether something is clean or not. Okay. So this is very good that we've seen it that way, to make something look neat. Okay. So cleaning is defined as the removal of all visible and non-visible soil. Okay. So even though you see certain things off it and think it's clean, the cleaning must actually take both what you see and what you don't see. All right. Those are the key words there. What we see and what we don't see, the visible and the non-visible. Okay. So if it's clean, it should be visibly clean and non-visibly clean. Okay. Do we all get that? So the goal of every cleaning process is the decontamination area. Okay. And that is where you have to get the cleaning right to decontaminate whatever is there. We've seen the visible part and the non-visible part. So if we talk of what is clean, it's supposed to come from the decontamination area. So our major goal today is that the goal of every cleaning process in the decontamination area is to remove all soils, not just the
Professor
ones.
Charles, a minute.
Yeah.
It looks like I'm showing the wrong slide. Give me a minute, please, if you don't
Oh,
mind.
okay.
Uh,
Okay, I think as director is trying to sort that. Okay, he got it right now. Cleaning and decontamination. Good. Because still going because most of the time, even though we have the slides to guide us, our discussion will be the primary source of knowledge for us. Okay, this the slides it's a guide, but we should always try as much as possible to listen to everything since we'll be having practical examples, that will be very, very good. Okay. So proper cleaning requires the right tools, the right technique, and attention to detail. This summarizes everything, okay? On the slide, it says cleaning is defined as the removal of all visible and non-visible soil, which we just said. Some soils are easy to see and remove, others are not. This cleaning must ensure devices are safe for use, okay? The challenges in cleaning medical devices, we have a list which says the complexity of the device design, presence of biofilms and residues, need for effective cleaning agents, and ensuring thorough cleaning without damage. Look at, we see biofilms there. Yeah, earlier on, I think Professor John told us about biobedding, and then now we've seen biofilms there. There's a difference between the two. Can anyone tell us anything about that? Biobedding, I know biobedding you remember because Professor John spoke about it. And then biofilms. Can anyone help? All right, let me just go into it. Okay, I'm going to talk about the biofilm. The biofilm, actually, it's difficult to remove more than the biobedding. All right, which as we go on, I'll give you a whole definition of that and tell you why it's difficult to remove. The biobedding is easy to remove, but the biofilm, it's more difficult to remove, okay? So we'll get into it as we keep going. So we know that the presence of biofilms will be a very, very big challenge to you to take it off, to get it removed from the instrument. And that's where you need effective cleaning agents, ensuring thorough cleaning without damage. When we will look at why we say without damage, it's going to tell us about brushes and what brushes we can use and what detergents we can use, okay? All right, so Director, I'll go on to the next slide. All right, so cleaning and decontamination, even simple instruments can be challenging to clean, which is a fact when you get to the SPD. Even simple instruments, they can bring you something like just a scalpel or like, what is it? Like a scissors, like a regular scissors at home, right? Used in the medical field, it's a whole different thing to clean, all right? So even simple instruments can be challenging. That's why we always say that at the decon, there's no compromise. How simple the thing is or how complicated it is, you have to adhere to the details and make sure you are looking at it as hazardous and infectious and can give you or your colleagues terrible time, okay? So that is one thing. Even though it's simple, there's no compromise there. Take care of it as it's complicated. Even the simple scissors, the box lock area, which is where the pivot is, you may think that it's clean, but that side may be harboring a lot of microorganisms, bioburden there. And if it dries, becomes a biofilm, there's a problem, all right? So that is what this slide is saying. Even simple instruments can be challenging to clean, which is something that you always have to put in mind. Director, let's go on to the next one. All right, so importance of personal protective equipment. This is what we spoke about the last time, and Professor John also spoke about. The PPE, we simply call, you see the image there, you see people wearing the PPEs. The PPE is an addition to your scrubs that you'll be wearing, all right? You see from the head down, their hands, everything. The personal protective equipment is essential for safety in various environments. Includes items like the gloves, mask, and gowns, which is more like a repetition of what Professor John told us. Standard precautions, everybody should know that by now. Basic infection prevention practices that we spoke about, breaking the chain of infection, keeping the environment clean, looking at the asepsis principles, the 5, all right? Applicable to all patient care. So this is more like a summary. So even though we said it was loaded, we see that we've done so many of them, and this is more like a revision of some of the past 6 chapters that we've done. Importance of the PP and standard precautions. I think someone should be able to tell us something about it. Is anyone ready to tell me something about that? The importance, why do you think the PP and standard precautions are important? Anyone, Gifty? Or Dorcas? Or Ibrahim?
Decrease the risk of infection and contamination.
Good one. You see, we have to prevent ourselves. And that is why we have the PPE, personal protective equipment. And then it reduces the risk of infection and contamination and protects both healthcare workers and patients How does it protect the patient? Can anyone tell us how it protects the patient? Is Shania here?
Yes.
How does it? Yeah.
From HAI.
Good one. Okay.
Okay.
The healthcare related infections, right?
Yes.
Healthcare associated infections. We have to know this PPEs, HAIs. We have to know those because they're not going to write it straight for you that, oh, this is that. If you don't know it and it comes in a test, that's it. Remember, you're losing that point and you don't need to lose 1 point. Okay? So those abbreviations, let's put them in mind. It's a good thing that Shania used it. She's getting into the profession right now. Okay? So that's it. It protects both healthcare workers and patients. And then the end result is the best patient care that you want to get or give. All right. Director, I'll go on to the next slide. My next question will be going to Tofik. So if Tofik, you are there, you get prepared, okay? It says the importance of chemical use. We use chemicals in the decontamination area, all right? So Tofik, tell me the 2 points right there. It says importance of chemical use. What are those importance?
Ensures thorough cleaning and decontamination. Prevent the
Ensures
spread of
thorough cleaning and prevent the spread of the contaminants. Okay, thorough cleaning, real cleaning, not just cleaning. Thorough cleaning. This is English, okay? So make good use of every word here. It matters. It ensures thorough cleaning. And we'll go into which chemicals and how they help in getting into the thorough cleaning and decontamination. And then it prevents the spread of the contaminants, which means that since you were able to control that, you're going to prevent the spread. You're going to break the chain of infection, okay? Well, types of chemicals used. Heidi, are you here? Or Ramsey?
Yeah,
Is
Ramsey.
Joseph around?
Yeah, Ramsey.
Yeah, types of chemicals used.
Disinfectants for cleaning pathogens.
Yeah, for killing pathogens.
Yeah.
Yeah, because these pathogens, as Professor Mike told us before, right?
Yeah.
They are like enemies to us. The bad microorganisms that we don't need. Disinfectants must be able to kill these pathogens, all right? So the types that we use must be able to kill the pathogens. What about the next one? It says detergents for removing dirt and organic matter. So we see that we're going to have different chemicals to talk about. And as we go on, we will talk about them. There are disinfectants for killing the pathogens, and then we have detergents for removing dirt and organic matter, all right? The next point says safety measures, which is proper handling and storage. If this thing, the sterility gets compromised before it gets to the OR, it's zero work done, no work done. So safety measures is something that we also have to look into. Proper handling and storage of the instruments. The use of personal protective equipment. You see that it has come back again. It's something very, very important. If you don't even use your protective equipment, you cannot ensure the safety of these instruments. Imagine carrying or loading the instruments with bare hands. Is it going to work? No. Is it going to be safe? No. For you, no. For the patient, no. All right. So use of the personal protective equipment is going to be one of your keys when it comes to decontamination. Application methods says manual cleaning with chemical solutions. That is what you'll be doing at the decon. We do a lot of manual cleaning before we put the instruments in the automated cleaners, washers. So the manual cleaning should be able to take all the bioburden, which is mostly what you see, all right? But that doesn't mean that no seeing it, it's clean, no. But then you're going to try as much as possible to use these detergents and other chemicals there to do your manual cleaning. So the solution should help you. Then the automated systems for consistent application. So you're going to follow a consistent routine to get the things cleaned from the decontamination area. Are we all on the same page? Are we all on the same page?
Yes.
Okay, there are some issues that before I go on to these challenges, let me tell you this. There are always residual protein salts detected on instruments after they are cleaned. But the only way we get to see them is when they use them under the fluorescence-based protein detection testing. You know, you think the thing is clean. But when we use the fluorescence-based protein detection, you see that there are images in the book that you may see, and they are colored, so you could see it very well. And it's scary to look at it because your bare eye say it's clean, but looking at the fluorescent protein detection, you see that it's not clean as you think. All right? And that is something that we have to put our mind onto. When you look at those instruments, it's very, very, very like disheartening that, oh, I cleaned this thing, and when I put it through this test, look at how it is. Okay? So we have to bear that in mind, that just cleaning it doesn't mean it's clean, clean, clean. Okay, so the challenges in cleaning medical devices, the importance of proper cleaning. Is there anyone going to talk about it for me? The importance of it. Is Joseph here? Oh, Joseph, yeah. I think I'm on Joseph today. Ramsey, can Ramsey say anything? It's right there. You see the slide right there. The importance of the proper cleaning.
Yeah, Ramsey is here.
Yeah, Ramsey, yeah, so tell me something about that.
Requires the right tools and techniques.
Okay, which you are learning right now, right? These
Yeah.
are the techniques that you are learning right now.
Yeah.
The right tools and techniques.
Yeah.
Then, what again?
Attention to detail is
crucial. Okay, and that is one thing that we say you cannot be doing that thing and then speaking on the phone with your earpiece, and then you're talking on the phone and doing it. Look at the story yesterday. This guy was doing he was not even supposed to go through to those instruments, right? And then he waiting for someone whose job was to dismantle the instruments. He's standing there and not looking on his phone. He went and got himself stuck by an instrument where he was not supposed to go. But since he was not paying attention to details around him, he got himself stuck and had to go to the employee health. You don't need that thing. You have to avoid it. Because everything, remember, everything there is infectious. That's the mindset. I don't know what patient was there and what happened, but look at it. And it was not in our department, but in a different department. So you see that it's not even just our department. Even outside of the OR, you can still get yourself stuck by a needle or something when you don't pay attention to details around you. Okay? So keep that as a key. Attention to detail is crucial in there. Hidden soils in medical devices. Devices may appear clean, but can harbor invisible soils. That's what I told you. We're using the fluorescent or even swabbing it to test, you see that the thing is not as clean as you thought. All right, just that after decon and the automated washers, it's safe to handle. That doesn't mean that it's clean, clean, clean. Okay? So always put that in mind. And that's why even at the clean side, we still use our scrubs and our gloves, the PPEs. We still have our gloves there. All right? In some areas, you're still going to have your mask and everything. Some areas not, but some areas, you're still going to be fully dressed because hidden soils in medical devices exist. Areas difficult to clean. So many instruments are complex to clean. Just the scissors that I told you has a box lock, which is with the pivot where the two, scissors is made of two pieces, two blades. All right. And how it operates, there's a pivot, there's a box lock. Technically, we call it a box lock. It's a pivot where those two metals meet and then they're able to rotate, like to operate, to cut. All right. Cleaning it doesn't mean that you can even clean under that pivot where the box lock. So at times you put the box lock down in a minute and you see that, oh, something is dripping from that side. It wasn't cleaned properly. It happens all the time. That doesn't mean you're failed. No, it means we need to clean it more, clean it better. All right. So there are hidden soils in medical devices and there are areas difficult to clean. Okay. Impossible to clean areas that cannot be seen, especially that box lock I'm talking about. And there are more complicated instruments than that. The lumens are instruments with holes in them, like pipes or hoses. Okay, technically we call them lumens. They are inaccessible areas and they pose significant challenges. You may have a lot of suctions. Okay, most of them are suctions. That's how we call them technically. The suctions, some are used to transfer a fluid, blood, things to suction it out or infuse it. Those things those channels need to be cleaned, and they are not easy. They are inaccessible areas, and they pose significant challenges. Okay. Any question up to this point? No
No.
questions? All right. So director, I'll go on to the next. Okay. So this is back to the importance of the clean. Okay. Even when item surface is clearly, it's like I'm saying the same thing over and over. This figure provides a look at the common clamp. We have some clamp that we call the mosquito clamp. I know it's funny. You guys gonna laugh about it, but this is not a biting mosquito. This is an instrument mosquito. Okay. It's one of the common clamps that you use in the ORs. You meet it. It's going to be one of the first instruments you meet. Okay. Most of them will come, you look at it, you think it's clean, but what they use it for, in there, it touches blood, it touches a lot of stuff, protein, it is. So when you put it, after you actually wash it, you put it under fluorescent-based protein detection testing, you see the residual protein soil on it. All right? And that's why we're saying that residual protein soil detected by this thing means that the thing was not properly cleaned. Maybe it was properly, but it's not decontaminated yet. It's not sterile. It's not sterilized yet. It's still there. So the importance of cleaning is to get those things off to the barest minimum so that it can be safe to handle at the clean side and go through sterilization. All right. Can we go to the next slide? So there are certain areas, you see, we're going to the decontamination area, and there are things that I have to tell you about this area, okay, the decontamination area. The design and location of the decontamination area, the staff must be aware of the following. The process of cleaning and decontamination begins long before even the soil instrument arrives at the decon area. Do we believe in that? I think all our professors that have come have told us about it. The process of cleaning begins long before the instrument gets to the decontamination area. All right. So when this is more of a work of the directors, when they're planning it, they look into so many things. The location of it, where they should locate it. It has to be centralized. It has to be near the OR. It must tolerate cleaning chemicals like the walls and the floors. Okay. You can use fiber shading materials, but this is the work of the directors. I hope one day this same group of students, somebody will be a director somewhere, because you are not just going to go in as a professional and stay there. Do we all believe in that?
Yeah, sure.
Sure. So you have to take care of all this. You know that there is a reason for siting the decon at a specific place. So you have to consider the location. It has to be centralized. It has the materials, the thing, how we talk about the one-way traffic thing, how the things are supposed to be positioned, and how you have to also follow the process to wash the instruments. Go one way, don't mix it up. We have our principles. So the area has this, that when you get into the system, you get into the department, at a point, it will be your responsibility to decide where we put our decon. And since you have been trained, you should be able to determine it and what material should be used, okay? There's supposed to be, we talk about some air exchanges in the decon. It's no less than 10 air exchanges per hour. You may not understand it now, but an hour is 60 minutes, right? At the decontamination area, there's supposed to be air exchanges, and it should be at least one every 6 minutes. And that's why we have 10 air exchanges in an hour. That is on most of the tests. Most of the tests that you'll be taking, you're going to see that the air exchanges at the decon is supposed to be 10 times in an hour. All right? Note it somewhere, because if you get that question wrong anywhere, you have a problem with me. You have to come and report yourself to me. All right, so the air exchanges is very crucial at the decon. And then the decon must always have negative pressure. Can anybody explain that negative pressure to me? I think one of our professors told us before. Can anyone tell me anything about it? About the negative pressure? Is Hardy there? Is Hardy there? Is Ibrahim there? Okay, the negative pressure is said that, okay, if you are in two separate rooms, right? One room is supposed to be like receiving the air, and one room is pushing the air out. The one that is pushing the air out can be seen as a positive room, right? Positive air pressure, because it's pushing the air out. The negative air pressure is sucking the air, it's receiving the air. So this is said that the decontamination area is going to have the negative air pressure so that it doesn't push the contaminated aerosols. I mean, aerosols are like droplets, okay? We say everything in there is contaminated. So the negative pressure makes it safer, such that the contaminated air, aerosols, and all those things from the contaminants from the decon doesn't go into the clean side easily. Do we all understand that?
Yes, Professor.
So and you will get it in almost every exam that you write on this, you will get the negative pressure because it's one of the basic things in there. The decontamination area is always going to have a negative air pressure. Why? Because we don't want it pushing the air outside into the clean side. And that's why we have our air exchanges, which is going to be 10 times every hour. And that air exchange doesn't mean that air exchange doesn't go into the clean side, it goes outside elsewhere. So that's another second question I've given you. You get 2 questions right now. You must not fail those questions. The negative pressure is going to tell you that, oh, the air there, it's like it comes in, it sucks it in, it doesn't pump it out. If it's pumping it out, that's positive, it's going to the next place. But this one is sucking in, such that the clean area is not going to have the droplets from the contaminated area. It's basic, you guys have to understand that, okay? Good. So you see that the slide that you have right now, I'm going back onto the slide, says the purpose of the contamination area is for cleaning soil instruments. It receives medical devices and equipment from surgery and other areas. The design, I told you, it has to be centralized. Centralizing the decontamination is cost effective. Why? Because it's right next to the ORs. Transporting goods back in there doesn't cost you too much. All right? Non-central areas incur additional expenses to transport these instruments back and forth. So, and I've told you the factors to consider in planning the area, the materials I need to use. All right, those ones are not that important to you right now, but some questions will ask you about it. The location of the decontamination area. You should be able to tell us about it, or tell whoever is examining you that it has to be centralized. Okay? All right. Director, I'll go on to the next slide. It has to be centralized. The light, you see, now we are on ventilation and temperature control. The importance of the cleaning tools, essential for maintaining hygiene. Do we consider water as a tool?
Yeah.
Good one. Yes, water is a tool. But since water alone cannot actually give us the clean stuff that we want, we add detergents to it. Good job. Who was that, Tafik?
Yes.
Good job, Tafik. Water is a tool. Okay? We must always remember that. If you are asked about tools at the decon, you should be able to mention water as one of it. Okay? It's essential for maintaining hygiene. And if we talk about breaking the chain of infection, water, hand washing is there. So why is it not a tool? It is a tool. All right? And it helps in efficient cleaning. So we talk of the cleaning tools too. Brooms, mops for sweeping and mopping floors. Imagine mopping the floors without water. How are you going to do it? So even though a lot of people don't mention it as a tool, it is a tool, all right? Vacuum cleaners for removing dust and dirt, sponges and cloths for wiping surfaces. They're all tools. The benefits of using proper tools, it reduces the cleaning time. Imagine you cleaning a lumen, right? Like a pipe, something with a hole through it. I'm very, very practical. I'm not going to be using just the terms. I want you to understand it. So when you see lumens anywhere, it tells you it's an instrument with a hole in it, with a pipe, all right? Like a suction or a hose, okay? Something that we suck water or liquid, any liquid through it. So these lumens, if you're cleaning it and you don't get the right size of brush, how are you, do you see that you're going to spend more time cleaning it? And we'll get to the point where we see the brushes and the sizes. If you get the right size, it goes in and out, and then you're able to clean it nicely. But then if it's like a 3 millimeter diameter lumen, and go and use a 4 millimeter, you're going to force it in, it's not going to work. And you use a 1 millimeter diameter brush, it's not going to clean it properly. So you need the proper tools. Always demand it from your manager. Tell your manager, oh, manager, I need this brush. And he's going to get it for you. That is his job. You have to just get the right things and use them. Are we on the same page?
Yes.
It ensures thorough cleaning, and then it prevents spread of germs. Okay? Because if you're going to use a small one, you won't clean it properly, it goes to the clean side, it's still not good, it's not cleaned properly. You are spreading the germs. You are not able to break the chain of infection. You have to break it by cleaning it properly. Are we good? So you see that it talks about relative humidity, amount of water vapor in the atmosphere expressed in the percentage of the total amount of vapor the atmosphere could hold without condensation. And there's a kind of humidity in the decontamination area. It's supposed to be 30% to 60%. Write it down somewhere. It comes in the test all the time. Humidity in the decontamination area should be 30 to 60%. I know it's in the book. We're going to get to it. It has to be 30 to 60%. Most of the time, it's going to be on the test. Okay? If it's there, that you have to understand that it's 30 to 60. You can't fail it. It's a bonus question for you. And then it talks about the temperature in the decon, which is supposed to be 60 to 65 degrees Fahrenheit. Everything I say is in Fahrenheit because America will use Fahrenheit. Even though some use Celsius, the books will tell you about the Celsius. I don't need it. I need only the Fahrenheit. That's what I'm using. So temperature in the decon, I said the air exchanges should be 10 air exchanges in an hour. Temperature in the decon should be 60 to 65 degrees Fahrenheit. Humidity should be 30 to 60%. 30 to 60%. I hope you're all taking note of that because I'm going to ask you later. I'll just pop any question to anybody, and I need this three. It's like 3 questions for you. Okay? So keep in mind, if you have to highlight it, highlight it. We talk of the lighting in the decon. Why do you think we need lighting in the decon? Somebody should tell me why we need lights in the decontamination area. Shania answered already. Who agrees with the gifting?
So you can see.
So we can see. Okay.
You can see. Yeah.
Essential to a safe work environment. How can you work in the dark? Like a funny story. Yesterday, my my light bulb in one of my biggest closet that I used to go in with the kids to go play. The bulb was off. It was fused out. I went in. It was dark. My little girl said, "Daddy, the closet is black." I can't see you. Are you in there? And I said, "Yes, I'm right here. I have to go get a bulb and come and put it back." So imagine that even me, a whole human being standing there, my daughter couldn't see me. So is it the same environment to work in? No. All right. So remember that you need lights in there. So that is one of the basic things that you need in the decontamination area to get a safe environment, so you don't get yourself poked with anything. Okay. And the decontamination area must have restricted access. Do we all believe in that? And why do we believe in that? Do we believe in that? That it must have a restricted access?
Yes.
Why do we believe? Is that Shania? Oh, yeah, that's Shania right there. So how? Shania, why do you think it has to be restricted?
So that for cleanliness.
Good one. That's the word I wanted, for cleanliness. Yeah. Somebody, like a dispatcher will come there dropping something off, and he wants to come into the decon to come and drop it off. That is a no-no. It's a restricted area. Not even the director of the agency or the CEO can walk in there like that. No. No, there's a no compromise over there. Not even the engineers there. If we have a problem and we call the engineers, they can't just walk in there. It's a restricted area. They must go and get the appropriate PPEs before they come in there. Before they come in there, one time I was at the decon, I don't know, my director may remember. I went to the decon and we had some officials there doing their inspection. So I went in there and asked if I could start working. But then I told them that if they're going to stay there for long, they need their PPEs. They can't just come in without PPEs. And my colleagues were laughing afterwards. Hey, Charlie, you were so bold to tell them that. And I said, look, that area is a restricted area. You have to be in the PPE to be there for your own safety. So I had to tell them that if you want to stay here, you gotta go get your PPEs. All right? It sounds funny, but that is a job. Okay? Take it like that. There must be, the PPE must be, it's a restricted area, highly restricted. Okay? There was a time there was a new housekeeping guy. He walked straight into an OR without a PPE, and he thinks he's cleaning. So the nurse manager yelled at him, "What do you think you're doing?" And the guy looked at me. I was also out there going to one of the sterilizers. He looked at me. And I could see that he was confused because he didn't know what was happening. He didn't know he was doing the wrong thing. And I said, hey, man, it's because of your dressing. You can't go in with that. It's the OR. He said, oh, my, I'm so sorry. So what can I do? So I had to go and put my instruments back and walk him to the dressing room where we get our PPEs, and to get him to get his PPEs. And then he came and said, thank you so much. See, he didn't know what he was doing. But he's supposed to be trained before he even gets to that area. But at that point, our aseptic principles come in again. I didn't blame him. I went straight to correct it for the safety of me, him, and everybody. Do we all get that? Do we get that?
Yes.
Yes.
Yeah. And you see, that's the fifth principle. Don't blame anybody. When you see that there's something is gone wrong, correct it right away. Don't blame anybody. And that's what I just did. I didn't have to think about it. I just saw that there was a misunderstanding between him and the next manager. But then the guy was confused. I could see it from his face. I just walked him there. I stopped my work, walked him there, get him. So we are all safe now. So always remember that's going to be something that you have to be doing. You don't have to think about it. It has to be second nature, like that. Okay? So I've told you the temperatures and all that. Then at the decon, there's supposed to be an eye wash station, which is always there. Why do you think we have an eye wash station?
Should in
Okay.
case you have a spill on your face.
Good, because you remember you're going to use these hoses and everything, this water, in case there's a splash and your protective devices are not able to protect that. You go straight. You need like the next 10 seconds to be there, and it's right there in the decon area to flash your eyes for at least 10 or 20 seconds. You have to flash it continuously. There are specific times that they give you, but it's right there. It's supposed to be there for you to wash your eyes right away. Okay? So when you go there, look for it, because it's for your own safety and everybody's. Right? There could be spills, but then you know that, okay, I can take care of that right here before I go to the employee health. All right? Where we go after injuries or our health issues is the employee health. From there, they just refer you, okay, go there and do this, and then they take care of you. They test you and see what is wrong, then they help you with it, okay? So we always have that kind of protection there, or that remedy, where if you get an accident there, you go straight to the employee health. There are qualified doctors there, specialists there to take care of you and make sure that you are safe, you are indemnified, if it's possible. Okay, that's an insurance term. Don't worry about that. All right, so that we make sure you are safe. Okay, and then the dress code goes back to the PPE, okay? But your personal behaviors matter at the decon, all right? Your personal behavior matters at the decon. Employee safety is an important concern at all times. Remember that, at all times. Assume that every item that you're receiving at the decon area can pose a potential risk to everybody, okay? Hand washing and frequent use of appropriate hand germicidal agents is required. We have them all over the OR and the decon. Every wall has this sanitizers and stuff around, and so you all have to do is just go and wash it. Okay. Alrighty. So are we good? So you see that so many times this thing keeps talking of the PPE, the PPE. You can miss it and you can't fail it. When it comes anywhere, you should be able to talk about it. Maybe when you are sleeping and your kid wakes you up and say, hey, mom, what is PPE? You should be able to tell her, right? Even in your sleep. All right? Okay, so the lighting and traffic control. That's the slide we have right now. It says lighting's role in safety. We discussed it already. Then the key element in cleaning process enables detailed inspections, okay, and then supports thorough cleaning. We've discussed that already. Instrument cleaning requirements, attention to detail, we mentioned it already. Proper lighting for effective cleaning, I told you about it. My daughter looked a bit closer. It was dark. He said, Daddy, it's black in here. I can't see anything. You can't work in that condition, okay? All right, so the importance of the PPE comes up again. All right? Assumption of risk. Every item in decontamination poses a potential risk. And that is why you need the PPE. I don't even need to ask any question on this. All right? That's why you need it. Then I'll go to the next slide. The traffic control, which it works with the work area. Before I come to this slide, The traffic control that we're talking about is not even on cars on the street. No, it's about our instruments coming in there. But then it should follow a flow, a pattern, one way. That's what I could say is a one-way traffic. So even the sink's position in the decon should go one way. You fill the water here, you wash first here, intermediate rinsing, and then the final rinsing before it goes into the automated washer. We're going to talk about that as we go on. The workflow must be from dirty to clean, a one-way traffic. All right, this is not traffic on the street, but traffic at the decon. Okay, most of the time you have 3 sinks at the in the decon. You'll be washing. One is going to be for washing. The second one is going to be intermediate rinsing, and the final one is going to be for thorough rinsing before it goes into the automated washer. So hand washing and hygiene practices. That was something that 3 professors have spoken about. Hand washing and germicidal agents, proper hand washing after PPE removal. Always imagine that after taking your PPE, you are not clean yet. Don't think that the PPE has protected you 100%. Please, proper hand washing after PPE. Technicians must wash hands after removing the PPE. Remember, the PPE is soiled in a way that your eyes may not see. There have been splashes of water. There's been so many aerosols. Aerosols are like droplets that when you brush, we're going to get there too. If you brush something above the water instead of under the water, you release aerosols, okay? Which could be harmful too. So when you take off your PPE, please wash your hands thoroughly, okay? There's always a sink in there for you to do that. It's not part of the 3 sinks that we wash in. There's always an additional sink there, okay? Which we call the emergency eye wash station, and then another sink there where you can, the emergency eye wash station has that sink with the eye wash, the pumps for the eye wash are separate, and the sink is there separate with another fountain or faucet for you to wash your hands, okay? And there's always a sanitizer or a soap dispenser there for you. Always look for it. If it's not there, please call the attention of your manager to it. If it's broken, call the attention of your manager immediately. Because hand washing is one way that you can break the chain of infection. All right? So there must be a dedicated hand hygiene sink. Director, let's go on to the next slide. So that the sink, okay, you see that, go back to that, okay? Now you see the images there. You see how they are dressed? That's how you're going to be dressing, from head to toe. From head to toe. The last time we spoke about how to put this PPEs on, it is a bonus question for you. It comes all the time, and people keep messing it up. The CDC recommendation is the best, and that's what we have in this book, which we did the last time in chapter 6. You can go back to it, and it says donning the PPE. Write it down somewhere. Let it be second nature to you, because it's a bonus question for you. How to put on the PPE and how to take it off. Donning the PPE and removing the PPE, you have to know it. It's a bonus question for you. I will not be there to remind you. I treated that with you in chapter 6. Go back to it. And the infection, the chapter 6 that we did. Go back to it, and infection prevention, it's right there, okay? We've done the work area setup that I told you, but mostly it's going to be the manager's job to set up. But then the way it's set up is for the one-way traffic, as I keep saying. The 3 sinks, one is going to be, mostly we're going to put warm water in it. The temperature is going to be like 80 to 110 degrees Fahrenheit. Okay? You see? This slice flow of soil items from dirty to clean, which I mentioned it to you already. All soil items should flow from dirty to clean. And here, that is a one-way traffic I'm telling you about. It must be from dirty to clean. That's the traffic. It must not be mixed up anywhere. So if the sink, you see in the image, you see 2 sinks. So this is the thing. If you have the 3 sinks, first one, as I said, is going to be for washing. The second one is intermediate rinsing. And the third one is rinsing, right? Thorough rinsing. But then the water in here has to be warm water of 80 to 110 degrees Fahrenheit. Put it down somewhere. The sink water should be 80 to 110 degrees Fahrenheit. So what you need here is the sink water plus the detergent, all right? You need a sink water plus a detergent. And here, a wash sink with water and detergent or enzymatic solution is what we need over there. You have to note that this sink should be filled with warm water with a temperature range of 80 to 110 degrees Fahrenheit. You can't feel that. It's going to be on any test that you do. The temperature, 80 to 110. Okay? You have to, these temperatures are something that you have to take note and keep in your mind. A second sink, intermediate rinse, contains plain or softened water. Plain or softened water. Okay? After cleaning devices, you should thoroughly rinse them to further assist in removing debris and detergent residues. Okay, this rinse water should be changed frequently or the cleaning chemicals do not build up. All right? Because if you keep doing the same water over and over, the detergents are going to build up on the instruments that you rinse it because the water is going to be a bit loaded with detergents and contaminants. So you need, the second one says that you need what? Softened water to rinse it. That's the second sink. And the third sink, which is the final rinse, with distilled, deionized, or reverse osmosis water. Note that it's always on the test. Distilled, deionized, or reverse osmosis water. Osmosis, I don't know about you guys, but I know I learned it all the way back where they said that my teacher brought some tubers of yam and we did an experiment where he said osmosis was the removal of water from a weaker solution to a stronger solution through a semi-permeable membrane. So when they say the reverse, it's now, it says remove, the first one says remove from a weaker solution to the stronger. So now it's from the stronger solution to the weaker solution. As simple as that. But I don't know if you learned osmosis in school like that. But I learned it in school, it was fun. It was demonstrated and it's still in my mind all these years. Okay? So you need that. The third sink is going to have distilled, deionized, or reverse osmosis water. You have to mark that. Okay? This helps prevent instrument spotting, rinse of cleaning chemical residues and pyrogens, and prevent the redeposit of minerals, okay, and pathogens. So these three things, you see that it's three different waters. The second one should be softened water, and then the third one is distilled or deionized water. That is not your job. The manager is going to make sure these things are there for you. All you do is open the faucets and get it filled to the levels. This tanks to the sinks to have levels in them. Our unit, we have a 5-gallon sink marked in there. So once we open it to the 5 gallons, my job is to close the tap after it gets to 5 gallons and then press the preset automated machine there that dispenses the soap, the detergent. Once I press it one time, it gives me 1.25 ounces for the 5 gallons. So every gallon takes 0.25 ounces of detergent. It's not for you to remember this. Your manager is going to take care of that and put it in place. But if it's not there or the system gets broken, you need to put this 5-gallon container of water is going to have 1.25 ounces of detergent, which is measurable with cups and other instruments available there. Okay? So now we see the three things. So you have to always check this temperature that I've spoken about. There's always a reader or a sensor in the sink. At my job place, we have a sensor in there which measures the temperature, and it's our responsibility to take good care of it, to make sure we look at it and see if we're getting the temperatures right, or the temperature matters in the cleaning. Okay? Does anybody have any question at this point? All right, this the current slide that you see says flow of soil items from dirty to clean, which I've mentioned to you. Technicians in the decon area must remain vigilant of their surroundings. I told you a story of somebody getting poked yesterday, not in our department, but somewhere in the hospital, in the OR. He wasn't vigilant of his or her surroundings.
Prof.
Hello?
Yeah, I'm sorry. I don't know, but I just want to ask this question. Sorry about that. What is the critical water?
Critical water?
Yeah.
All right, some books will put it as critical. Okay, I told you the three okay, we're gonna get there where we have this
Okay.
the
All
pH.
right.
Hello? Where we
Okay.
have the pH, where we measure the alkaline of the alkalinity of the water, right?
Okay. All right.
You're
I
gonna
just
get
want
it.
to know if you're gonna get there.
Yeah,
That's
you're
fine.
going to see all the levels, okay?
All right. Thank you.
All right. So we're going. I'm gonna make sure we finish this. We finish the chapter, so you get all that. The pH and everything is in there as we go. So right now we see the flow and the wake area, which I spoke to you about. So we don't need to waste time on this slide. So director can go on. But then I'm gonna tell you that, as I told you, water is a part of the tools. We have brushes. We have water, and regardless of where the water originates, a neutral, aquifer or whatever. You know what? I don't know if anybody has done well sinking before, where we drill and get water. You see, these are the images of the brushes, different sizes, all over there. You see some are big, some are long, different sizes. You have multiple brushes in there. This image is very clear, so you see the sizes and how they are for the lumens and all that. Examples of cleaning brushes. Use a correct brush size. Examples of forced air, where we use pressurized air to clean the lumens after we wash them. You know, the pressurized air, like the one that they use in pumping car tires, we have cleaner ones, not just that one, not that kind. But we have cleaner ones from compressed air cylinders that we use in cleaning and like in flushing, like forcing air through the lumens to make sure the debris are all out. All right, we have that. So the images they do justice to it. So one thing I want you to understand is that no matter where the water is coming from, that's what I was going to tell you. Even boreholes that we sink down, they're supposed to be the purest water that we're getting from the aquifer down below. That is not even pure in healthcare. Okay? And that's what it's telling us here. As water as a tool, even from any source, typically, it's not as pure as we think. Okay? Some water sources contain bacteria, algae, parasites, and all that. Okay, so these contaminants may impede cleaning. And that's why we have those specific water qualities that I told you of, the softened water and all that. But we'll get into details as we go. You can understand the pH and which levels we need. All right? So every morning, you may not, I don't know which department or which shift you'll be taking, but at my department, the morning shift people, they test the water every morning. They test the autoclaves, they test everything that we use. Every morning they have to test it and make sure it's good for use, okay? It falls within the standards that we know. Knowing the pH and what is the water is used in the process of instruments is always good, because if it's not the required pH, it means you don't have to use it. You have to inform your manager right away. So I'll tell you about the pHs very soon. So now you've seen the what is this thing is telling you about the manual cleaning tools, the brushes, the cleaning cloths, water irrigators, and then we have some sponges that are already impregnated with soap or detergents for cleaning endoscopes, flexible scopes. You get to that. And scopes are more like cameras, like video cameras that are used for medical diagnosis and stuff. They aid in this surgery where they use this and laparoscopic instruments to see inside the human body and try to do invasive surgeries, okay? But then the cleaning is on you. Some of them will come with pre-soaked or impregnated, that's what they say, impregnated sponges with special detergents on them that you use in cleaning the endoscopes, the flexible scopes, all right? And then it talks about water irrigators and forced air, which I told you. And then the floor drains and spray nozzles. We have spray nozzles that we rinse, usually using in rinsing the instruments after we wash them. They are all the spray nozzles. And then the drainage that is talking of the floor drains. A lot of time water is going to spill on the floor. There must be a drain to take care of that, even though that's the work of the housekeeping people. But always make sure if there's no drain, water gets stagnated there, let your manager know, because it's not good. It's not a safety measure. All right? Okay, so now, Director, you can go on to the next slide, but I'm going to tell you about the pH levels. Okay, the floor drains and spray nozzles. These are the spray nozzles that you see spraying onto the instruments, and this is the drain. So you see that thing there whereby we know drains. When we walk in the street, we see drains where rainwater runs through. you need a drain at the decon so that any spilling water and stuff could go through there. You don't need to be working in stagnant water. Many decontamination areas are equipped with a spray nozzle and floor drain. Okay, that provides drainage when manually cleaning bulkier items that do not fit in the sink, the cleaning sinks. You know, we're gonna wash things that don't fit in the sink. We have at my end, we have this micro flaps that we wash. Some of them fit in the sink, some don't. And so it means you're going to be splashing a lot of water trying to wash it. There must be a drain to take care of that after you wash, okay? And there are some areas they even wash carts, which are big. So definitely there's going to be a drain that has to take the water out. Not everybody will work in those areas, but you need to know about it. So Director, I can go to the next slide. And then very soon we'll be taking a break at 4:15. We'll be taking a break at 4:15. So this one says mechanical cleaners. Okay, so now you see this image, it says overview of mechanical cleaning options. These are the machines that we use. After we do the manual cleaning, these are the machines that we use in cleaning, in washing the instruments. Mechanical cleaning facilitates contamination by removing soil and microorganisms. It uses an automated cleaning process, and that's why we say automated washers, all right? They are programmed so that we put it in and say, okay, this is the cycle that we want. Just like the laundry machines, when you go in and you want hot wash, you have it all there. This is also programmed like that with temperatures and everything.
Professor Charles, let me slide this in now. The image that you are seeing on this slide is wrong. That's quite misleading. It's these are sterilizers. They're not supposed to be here. The person who designed this is not a sterile processing technician or manager for that matter. This is not his field. So these are sterilizers, just to point that one out. We would remove that as soon as possible. Also, Joseph, going back to your question, we'll get to that as Professor Charles has rightly indicated. But just in case, you have to step away for a little while. Critical water, when Professor Charles was talking about water, he did mention that even the most purest water that we think we are getting from the pipe-borne water is not really clean. It has a lot of particulate, it has a lot of chemicals, and the chemical composition in it is not good for our instrument. But for you to get the best water, you will need to take it through filtration system. And one of the filtration system is osmosis. And he used YAM. Yeah, he did rightly mention that in our high school days, those days when we say we are going to do experiment, they bring YAM to the class and show you how water move from a region of higher concentration through a region of lower concentration. That is a process of filtration and osmosis right there. However, when it comes to CSPD, the way we filter the water is that we have a whole system. There's a company called Avaqua. Avaqua will come install an equipment in your facility where before the water gets to your washers, they go through that system where microbials, chemicals, and particulate contaminants are removed and reduced and are completely removed. And some of the water will be pumped through the sink, through the cart washers, and also through the automated washers. To summarize, critical water is the water that meets all the specification that is needed and recommended by the regulatory bodies for final cleaning. Thank you.
All right, thank you, Director. So, okay, as we said, the images here are autoclaves. You'll be doing it. The autoclaves are the sterilizers. Yeah, the sterilizers. Okay, so the washers are similar images with carts that we put in, like the laundry machines that we have. They're like that. They have doors that open. You put the instruments in there on carts, and then they have sprinklers, not like the ones in the laundry machine. They're different spray arms. So those ones, they clean it differently. We'll go into that. We talk about ultrasonics and the automated washers and how they all clean and the processes that they use. All right. So now these images, they are autoclaves. You're going to get there. You're going to use them for sterilizing. Okay. All right, so it says mechanical cleaning. I spoke about it. It says consistency and efficiency. Machines function consistently when operating correctly. So you should know the circle and you should just press that circle. If it's not working, let your manager know. And that's the word I was telling you as director explained right now. If you go and the temperature is not up to the standard, the device is not reading right, let him know, because there's a system that is bringing you that water. The system has to be corrected right away. Okay? So you see, most of your job will be to measure these things as per the training that you're getting and make sure that you're doing the right thing with the right tools. All righty? Are we all good?
Yes.
Okay. So we talk about, why do you think, if we have all these washing machines, why do you think manual cleaning is still needed? Why do you think manual cleaning is still needed if we have all these automated washers?
To ensure a proper 100% cleaning.
To ensure proper cleaning. I mean, I would take the 100%, but I know it's to ensure proper cleaning. The 100% we may not be sure about that. Remember, I spoke about the fluorescent test. Yeah, we may wash it, but that is still going to be something there. But at least it's going to be safe to handle after we do manual cleaning and put it in the automated washers. All right?
Okay.
Okay. So that is it. It has to be cleaned properly. Even though it may not be 100%, it's going to be safe to handle after that. And that's where we're going to inspect it and assemble it, and then we sterilize it before it goes to storage and then transport it to the OR for work. All right? Are we all good now?
Yes.
All right. So can we go to the next slide, Director? This is loaded, but we're doing good. So far, I like the way we're going. I made mention of the cleaner equipment used in there. We have the ultrasonic cleaners, we have the washer disinfector, we have the automated cart washers. Some hospitals use cart washers, which are huge, as I was telling you about. And then some have automated endoscope. Hello?
Just let me add that these are the images that are supposed to be on the other slide. These are a good example of these are good examples
Washers.
of washers, and these are ultrasonic washers. So just to point that one out. Thank you.
Right. So you're going to see the ultrasonic washers, and then we're going to see the washer and disinfectors. But the point is that they are washers that you're going to meet there. You don't have to do anything about it. You're just going to meet them there because they have to be there for you to use. All right. So the image is just going to tell you, oh, when you see that, you're going to guess it right. Oh, that should be the ultrasonic right there. If you've never been in there, that should be it. And when you see the autoclaves, okay, that should be the autoclave, the sterilizer. All right. So these are just to guide you. Just look at the technicalities of them, and then you should be fine. So these washers are all different, and we're going to talk about them. The ultrasonic washer, it's ultrasonic. Yeah.
I'm sorry to be interjecting every now and then. I just want us to, because this topic is very important to me, I want us to engage the student also, so that those who are sleeping would not be sleeping. All right. Guys, yeah, when people go to interview, CSPD interviews, some of the questions that sometimes they ask them, especially if they doubt that if your experience, is to mention 4 equipment that you use in decontamination. For every job area that you can think of, before the getting in is the problem, which means that your first interview will be one of the most difficult interviews. However, if you listen to what we are telling you and you follow our program well, your first interview for that matter should be very easy for you. There was a time someone came to me with a resume with 2 years experience, and I asked her to mention some of, how a day is like when she works in the department. And she said, oh, as for me, the only thing that I do is decontam. I only do decontamination. And I asked her, okay, I do understand if you don't have a lot of experience. Sometimes managers think that they will get more value if they put you in decontam than put you in a place where you might make a mistake, or put yourself at risk. So now tell me 3 equipment that you can find in decontam. and they couldn't tell me. So now I have to go change the format of the interview to really test if someone really wrote the exams for her. I'm not saying it's possible, but this is 2024. I mean 2025, so anything is possible. When I probed further, I found out that, she found a way to pass the exams by going through, some question and answers, some schemes, but really, really going through the material or sitting like how you professionals to be are taking through. She didn't get that. So I don't want us to go through charisma SPD certification and stuff and go for any interview and not be able to identify even the simplest equipment that you can find in our areas of operation. So you got to know equipment that you use in decontamination area, equipment that you use in assembly area, and we don't use a lot of equipment in the storage area except computers and stuff like that. But you need to know not only for the exams. This is going to follow you everywhere. And also some places when you go, the interview is a walkthrough interview. They just take you through the department and they'll be pointing things out to you. What is this? What is this? What is that? Some places they might even give you a tray and ask you to do it. So please be mindful. And when you are reading, don't just, read just so that you pass the exams. Make sure that you understand them. Thank you.
All righty. So before we go for a break, let's do this. We have the ultrasonic cleaners, right? So thank you, Director. Those are you see, I give you a lot of questions that are possible, but also remember the machines that we point out in these areas, the sinks, the washers, all right? The spray nozzles, they're all there. And the air exchange and things, they're all there. You have to know them because practical, most of this interview, being a technician or professional is going to be more practical than academic, okay? So the ultrasonic cleaners that we see, ultrasonic actually is more like beyond sound. I think that is the actual meaning. Then ultrasonic cleaners are used for like fine cleaning, not for disinfection or sterilization. That is something that you should know, okay? They are used to remove soil from joints, crevices, lumens, and other areas that are difficult to clean. That's ultrasonic cleaning. The term ultrasonic is an appropriate name for this type of mechanical cleaner. Ultra means beyond, and sonic means sound. So I was right, selling is beyond sound, okay? And then we're talking about the cavitation process, which the ultrasonic uses in cleaning. Ultrasonic waves generate rapid vibrations in a liquid, creating gas bubbles that implode. Look at that, implode. We know of explode, right? A lot of times we talk of explode. This one is not explode, this is implode. All right? So instead of exploding, like bashing out, it implodes, goes within, producing a vacuum effect that dislodges debris from the instrument surfaces. So if they ask about the cavitation process, it's about ultrasonic cleaning. All right? Hospital ultrasonic cleaners operate at 20,000 to 38,000 vibrations per second. And it is through these vibrations that the bubbles implode and produce a vacuum that dislodges the debris from the instrument surfaces. All you need to know is the cavitation process. It must be a second nature to you. Even when you're sleeping and ask you, what is it? Oh, it's associated with the ultrasonic cleaning, and that's how it cleans. It uses waves to generate rapid vibrations in the liquid, all right? And then remember the implosion, it implodes. It doesn't explode out, no, it implodes. It's like it curves into it. And in that way, it vacuums it out and cleans it, okay? So that's about the ultrasonic. The post-cleaning maintenance. Rinsing is essential, and this is one of the questions that always come. They ask you, is it essential to rinse something after it's been cleaned in the ultrasonic machine? Rinsing is essential after cavitation to remove detergent residue. That is a bonus question to you. Regular cleaning of the ultrasonic tank, as per manufacturer guidelines, is necessary to maintain effectiveness. That is a machine that, if you use it, it needs regular cleaning. So if you go to a place where you're going to have the ultrasonic, it means that it needs you every time you have to clean it as per the manufacturer guidelines. which is the IFU. So post-cleaning, keep it in mind, rinsing is essential after cavitation, okay? And then the cavitation is the process that the ultrasonic used in cleaning. I'll go to the next slide. I think it's 410. So I think I'm gonna let us take the break now from 410. When we come, we continue with our washer disinfectants. All right, we're going at 410 and we're coming back at 425. When we come back, it's gonna be a lot of questions and answers, so you gotta be alert, okay? So let's take a break now from 410. We'll be back at 425. Hello, director?
Yeah, yeah, let's go to break now. Yeah.
Okay.
Uh-huh.
Do you all understand that? Do you all understand that? The spray arms are like propellers of the helicopter. You see the helicopter in the air with the propellers spinning. That's how the spray arms spin, but they are smaller, not as big as the helicopters. They are smaller to fit in the washer. And they spray with holes out there that they spray the water through. So the water is sprayed forcefully to remove the bioburden. Okay? So similar to dishwashers, they rely on water temperature, specialized detergents, and spray force to clean effectively. So proper positioning of items is crucial for this optimal cleaning. Do you all understand that? So the impingement is something that you have to always remember that, oh, the automated washer uses this as against the ultrasonic, which uses the cavitation, which implodes, right? It's about implosion. And this one is about force pressure through the water and the temperature and the detergent, and then it gets this bioburdens out. Are we clear with that? Because it's a key that you have to go with all the time. A lot of the times, I don't know about anybody going to write the test and not meeting that is going to happen. And at times it's confusing because we don't know which one is cavitation and which one is impingement. But I've told you the cavitation goes with the ultrasonic, and then the impingement goes with the washer disinfectors. Are we cool with it? So the impingement, you can see the definition in those green or gray boxes. Make good note of it. The spray, it's the spray force action of pressurized water against instruments being processed to physically remove bioburden. Okay, so that is it. That's the impingement. Director, can we go to the next slide? There were certain things that I wanted to tell you guys about the ultrasonic washer. There are certain things that don't go in there, and that's chrome plated or ebonized instruments. They don't go into the ultrasonic. Needles, unless approved by the IFU, they don't go into the ultrasonic. And instruments that contain fiber optics, they don't go into the ultrasonic. Okay? So always take note of that. The washer disinfect continuously.
Can anybody take a guess, Mr. Charles? I'm sorry. Can anybody take a guess why those cannot go in the washer? Like a guess?
It will get damaged.
Why?
Because they are tiny.
No,
No, because it's like electric, because of the ultrasonic.
exactly. So on your first day, when you go, just make sure that you examine every instrument that comes through to make sure that you're not putting anything that has electrical component in it. It might damage. It would damage. Make sure you inspect that. So for anything that looks like it has a cord or it has wiring in it, ask if this goes in the washer or not before you go ahead. All right, Charles, go ahead.
Alrighty, so that is a good one. What was that, Shania?
Yes.
That question is a good one. Good job, Shania. Of course, these are the kind of things that why you have to pay attention to the details around your surrounding when you go in there. Everything is like you're in a different world. Everything has to be like, oh, your mind has to be on the details of it. Okay? So guys, as we answer these questions, it should be like just take note of it. Because you see it. All right. So we're still talking about the washer disinfectors, the types and functions. There are two main types: the single chamber models performing all functions in one chamber, and index models moving items through separate chambers for each step. It depends on where you go. Some places you want to see the single chamber. Some places you will see the multiple one. Washers often feature multiple cleaning cycles for different instruments with the multiple ones. So they tell you, okay, here, this is what cycle that we use. And there are codes on them. You don't have to worry about the codes. Just worry about what cycle you'll be taught to use over there. Make sure that cycle is on whenever you pressing it, you're turning it on. It's like going to, like the IFU says that this thing has to wash under this temperature. That is where it's going to be set over there, and that is what you have to use. All right. The washing cycle, which is the steps. The cool pre-rinse uses a cool water or enzymatic solution. We're going to talk about the enzymes later to prevent protein coagulation. You see how, like, when you put oil in the cold temperature, it coagulates. It becomes a bit hardened, right? We use the cool pre-rinse water or enzymatic solution to prevent that protein coagulation. Detergent cycle, which is different than the washing cycles that we're talking about. The detergent cycle uses higher water temperature to enhance detergent effectiveness. So we always talk about the temperature, all right? And then the rinse cycle removes residual detergent and debris, sometimes including a lubrication cycle. Because most of the time when these things get washed out and comes back, and you are assembling them, they become stiffer, like the scissors, it's stiff to actually close it, to operate it. The mosquito that I was talking about, the forceps, they become a bit stiffer when you're trying to close them. All right, the ratchets and stuff. So some cycles include a lubrication cycle. All right, that is not for you. The system is set up that way. All right. So that, but when it comes, it's going to be a bit softened to actually operate. The scissors will be smoothly operating when they has that lubrication. If not, you have to lubricate it after inspection. Okay, so those are the kind of things. The steps of impingement is also there that you're supposed to know, and that's it. Okay, these three that you see are the steps of the impingement, where the first step is the cool pre-rinse, the second is the detergent cycle, and the third is the rinsing. Okay, any questions? Okay, so the next images that you see are examples of small part holders and stuff. Like if you're washing, at my end, we have an eye clinic that bring eye instruments, very, very, very tiny instruments. You have to find a suitable container to put them in. You just don't throw them into the washer. You have to find a suitable container so that the tips are going to be protected, and you put them in and you wash through so you can get them back. All right, there'll be images that you see, and those are the kind of things that you have to be looking at. We saw the images already, so I'm not going to waste time on it. So some important factors for the dishwasher, the washer disinfector. Who can tell me? I think I don't know if you guys read it. Before I come to the cat washer, let me talk about that. It says that the washer racks should never be overloaded. Okay? Never overload the racks. There are racks in the washer. Don't overload it. They're putting things on top of others. And no, it's a no-no. All right? And the instrument should be disassembled, and there are small parts placed inside an approved container. That's what I'm telling about the eye clinic things they bring to our end. At times they bring other instruments they have to disassemble, dismantle it, put it in special bin trays, and put it in there to wash. Some net baskets to wash. Okay, those are the important things. Don't overload it, and then make sure those that need to be dismantled or disassembled, you do that so that they can wash thoroughly. All right, and then hinged instruments should be opened to permit direct contact of the water. If it's hinged, don't keep it closed. It has to be opened. Those are the important considerations. And the same thing comes with the cart washers. Originally designed for clean transport carts, modern cart washers can also process rigid containers like the bins and the canisters. We call them canisters at our end, like the canisters that we use. Most of them are made of, they are metal, actually, hard. Okay. Beside the surgical tables and stuff that the cart washers do, these washers function similarly to automated instrument washers, but on a larger scale, using high temperature water, detergent, rinse cycles, and hot air drying. Unlike washer disinfectors, the cart washers generally lack multiple phase cycles, but incorporate high temperatures to reduce bacteria. So you see that temperature is one of the basic factors in our cleaning. All right. The considerations here are that ensure enclosed carts are approved for cart washer cleaning. Do not process instruments in a cart washer unless specifically designed for that purpose, which goes back to the IFUs. Okay. Items should not be placed inside carts during washing, as the cart walls block cleaning solution and rinse water. That's easily understandable. When you go in there, you look at how the stations are built and how the washers are built. You don't have to do that. You should not place inside carts during washing. You should not put items in there. Okay? Items should not be placed in there. Regular testing of cart washer cleaning effectiveness is necessary. And that's what I said at the Decon or at the SPD. Every morning is a series of tests. Series of tests. Testing the washers, testing the autoclaves, testing everything. Okay? So that is something that goes on at the Decon all the time. Let's now get the next slide. So with these washers, you have to always look at that side of it. Debris should be removed from the washer traps daily. When you go open and look in there, at times there are instruments that are falling in there. You take them out. If there are debris, take them out before they block the drains. Okay? So always pay attention to that. Like our side, we have an instrument like the Baja drill. He has tiny, tiny instrument parts in there. You have to be very careful with those instruments or they're going to fall off into the washer. And that is one thing that sometimes when we go at the end, we pull everything out and you pick some of those instruments from there. By the time you go to the other side, they're already on the side awaiting those instruments. So you clean it, you take those ones, clean them and go for, and help them to be able to complete those instrument sets. All right. Any questions? All right, now go to the automated endoscope reprocess. Endoscopes, I told you, does anyone know anything about an endoscope? Have you seen an image of an endoscope? Anyone? They are more like flexible, like cameras with flexible ducts and stuff that are used in the medical field. They are more like video cameras. They give clear images. They help the doctors to look inside the body, to do diagnosis, they even aid them with surgeries. Okay, they get a clear view, they get a minimal cut, and they're able to see through everything. These endoscopes are special instruments. They are camera lights. Okay, and then we have automated endoscope reprocess for cleaning these endoscopes that we're talking about. Okay, they include some of them, as I said, we do that by just hand washing, and we use special sponges for it. But then those that have the machine for the automated one, there are key considerations when using this automatic endoscope reprocess. If you don't have it there, it's a different thing. But if you have it, you have to pay attention to these key considerations. Only process items specifically approved for the automated endoscope reprocessors. Don't put anything else. All items must be manually cleaned before placing them into that unit. Use only cleaning chemicals approved. As I said, that some come with already impregnated sponges that we use because they are very delicate and very expensive. All right. Regular testing of the equipment is essential to ensure proper functionality. When after cleaning, we test it at the Decon before we wash it. We make sure there are no leakages. If there are, we don't do that. We clean it and then it has to go for repairs. But if there are no leakages, then we completely reprocess it. All right. So that is a machine that you'll be seeing there. Not all places do endoscopes. but most places that do it, you see the reprocessor. If you don't have it, there's also another way to process it by hand washing, okay, or manual washing. Director, I'll go to the next slide. Equipment testing, as I told you, we have standards and they do a lot of testing every day. Some are like every machine has to be tested in the morning, especially when there's like a fault, a repairs, a gas shut off. The testing is even done rigorously. At times, the test that you do once, sometimes going to be 3 times before you can start doing the normal reprocessing. Okay, so that is equipment testing. There are standards from ANSI and Army. We have it. They have recommendations which ensures mechanical equipment is functioning properly. These are standards that you have to follow. You don't just do it, right? They give you recommendations. So those are like the parameters for you. Don't do it until you are able to get to this level. You have to follow it for quality assurance. It verifies the cleaning effectiveness of the equipment. The washers have certain things that we put in that have to wash to a certain level, and then we read it and then like mark it up. But then those records have to be there for inspection in case any supervisory body comes in and asks for it. You have to be able to show it, and that is what that is about. Quality assurance program. You have to make sure the quality is being preserved. So equipment testing is a must. When you go, you're going to be doing it a lot. They will show you how to do it. We have leak tests. We have all those tests. You have to know how to do it because it's going to be part of the work. Don't just skip it and say, oh, no, they told me to do it 3, but since nobody was there, I did once. Quality assurance program, please follow the standards. There are standards that are set up. This ST79, you can get the whole thing online if you want to go into it, but there are books that have it too, okay? And then commercially prepared products used to verify equipment cleaning effectiveness. There are things that you can use, like I told you about the fluorescent test. You can get those commercial things and buy and test it, but then that's the job of your manager, not you. You are not going to do that. But if it's there, you're going to be using it to test, to make sure that, oh, this equipment is working right. After we put this in, it came out. There are some equipments that will tell you this failed. You can't use it until it passes. The washers have it, the autoclaves have it. If it fails a test, it cannot be used because of quality reasons. All right? So these are equipment tests. The equipment tests from the washers, the sinks, the water, the autoclaves, everything has to be tested. Are we on the same page? You see the images on the right? Those are some of the equipments from the washers to the autoclaves and everything. Everything must be tested to make sure we're meeting the standards, the ST79 standards recommended, okay? Any questions up to this point?
No.
Okay. So from now, from this point going, okay, the cleaning chemicals and lubricants. You guys are not going to be telling me. I don't want to mention names, but we're going to start from here. Who is going to take the next slide? Director, give me the next slide. Okay. Cleaning chemicals and lubricants. I want someone to take this whole slide and read it to us.
All right, I'll read it.
Okay. Thank you. Who is that? Hadi?
Yes.
Good job. Hadi, let's go.
Cleaning chemicals and lubricants. Challenges and cleaning medical devices. Dried blood and soil can be difficult to remove, especially in joint, hinges, and crevices. If not properly cleaned, biofilm can form, making instruments harder to decontaminate. Proper cleaning chemicals in the correct concentration help loosen and remove soil efficiently.
Okay, hold on from there. Okay, you see, I spoke about biofilm initially, right?
Yes.
I said the biobedding is easier to clean than biofilm, all right?
Yes.
Biofilms are notoriously difficult to eradicate. Okay, they can lead to device malfunction and can also help lead to the HAIs, as Shania said earlier. They require specialized treatment methods to actually clean them, the biofilms. It's a complex community of microorganisms, all right? And they produce some kind of protective substances around the microorganisms, which makes it very difficult to clean. So when you see microfilm, biofilm, be careful with it. Don't wait till the biobed is dry up and get to the point where you have a biofilm on the instruments, all right? Okay, so it's a challenge if you have biofilm. You need extra cleaning. Okay, go to the next one. Types of cleaning chemicals.
Types of cleaning chemicals. Enzymatic cleaners.
Yeah.
Biodegradable non-toxic agents that break down organic materials like blood and fat. Second point, used for heavily soiled instruments and those with lumens. Enzyme
Okay,
types.
hold on with that. So the enzymatic cleaners that he just said, these are characteristics of the enzymatic cleaners. They are biodegradable, non-toxic agents, and they break down organic materials. That is what I want you to understand. They break down. So when you even put the instrument in that solution, like the water, with that enzymatic cleaner, it starts breaking down the bioburden on there. Okay? Like blood and fat, it starts breaking it down, even though you haven't touched it. Are we all there?
Yes.
Okay. And so it's used for heavily soiled instruments and those with lumens, which I've told you, those that have channels through them, the lumens. It's confusing now, but when you go there, you're going to see a lot of instruments with channels through them. And this thing, the enzymatic cleaners go in through that, and it's able to break down the organic materials in there. All right? So let's go to the types.
Enzyme types. Protease breaks down proteins into black blood, mucus, and feces. And then lipase breaks down fat into bone marrow, adipose tissue. And then amylase breaks down starch. Enzymes degrade over time and require optimal hydration and proper temperature to below 140 degrees, 160 degrees Celsius for
All
effectiveness.
right. So you see what we've just seen now. It's telling you there are three types right there. One breaks down proteins like blood, mucus, and what feces, and some that's the protease. The lipase breaks down fats like bone marrow, adipose tissue, and then the amylase breaks down starch. You have to know these three because a lot of times they trick you with these three and ask you that, oh, what does protease enzymes do? They break down proteins, right? So be careful with these three. You have to actually know the difference. There are three examples of three types of the enzymes, and they all break down stuff. One breaks down proteins, one breaks down fats, and one breaks down starch. Okay? And they degrade over time and require optimal hydration and proper temperature. When we talk of hydration, like when you are dehydrated, it means you are dried up. You're running short of fluids. So if you are hydrated, you will have enough fluid, right? So they require optimal hydration and proper temperature below 140 degrees, which is the temperature that we use. We are always around below 140, 110, 109, right? So it's good. These enzymes will be effective in our situation. Any questions? Thank you so much. How is that, Hardy, right? Thank you so much. Okay, now we are on the detergents. Who is going to take out the detergents? Somebody should take out detergents. Somebody
I'll
to take
take
out
it.
detergents?
Yeah, detergents.
Okay.
Natural detergents, pH
Mhm.
6 minus 8
It's 6 to 8. Okay, pH 6 to 8.
to 8.
Hold
Okay.
on for a minute. The pH, as I said, it's like a scale for measuring the alkalinity of water, right? And then we have the soap, pH 2. They range from 1 to 14, I think, in water. So when you see 6-8, it means the pH from 6 to 8. All right. And then the next one is 8 to 11. It's a plus. And then the next one, 1.6 to 3. Those is a scale. Okay. I'll have a page that I'll explain it to you. So let's go. Last topic.
It's Johara topic. Yeah.
Jahara, yeah, let's go. Thanks.
Safe for aluminium, effective on inorganic soils.
Okay,
Less
so
effective
we're telling you that the neutral detergents would have the pH of 6 to 8 are safe for aluminium, effective on organic or inorganic soils. Less effective in hard water. You see that? If the water is hard, it's not going to be effective there and can produce excess foam. Remember, we don't want so much foam when we are washing instruments. Why don't you want so much foam when you're washing instruments? Can anybody tell us why? Why don't you want so much foam? When you see, when you're washing clothes, you want so much soap and so much foam. With
Because of the
instruments,
error
you don't
channel.
want it. Why?
Because of the error channel.
Yeah, so that the water should be clear. Yeah, good. So that you can see what is in there and you don't poke yourself with anything. Okay? And that is one thing why we don't want excess foam. So that if it's hard water, this neutral detergent of pH 6 to 8 is going to give you excess foam. Okay? So continue for us.
Alkaline detergents, pH 8 to 11 plus. Highly effective for removing organic soils, blood, fats, oils. Require thorough rinsing and cannot be used on bronze, copper, or aluminum.
Good one. You see, it requires thorough rinsing. Why do you think it requires thorough rinsing, the alkaline detergent? Why do you think it requires a lot of rinsing?
To make sure it's clear.
To make sure it's clean. Because there may be some residue, there's some detergent residue on it. Because it's pH 8 to 11. Okay? So it requires thorough rinsing and cannot be used on bronze, copper, or aluminum. Good job. Continue for us.
Acid detergents, pH 1.6 to 3.
Mm-hmm.
Remove mineral deposits, hard water, urine, scale. Can damage stainless steel, aluminum, and glass.
Okay, so you see this, the pH is 1.3 to 1.6 to 3. And it's good to remove mineral deposits like hard water, urine, scale. Okay, so we know when there's hard water, there should be a lot of scales on the instruments. This one can remove it, but then it can damage stainless steel. You see, like most of the spoon and stuff that we use at home, most of them are like stainless steel. Most instruments come like that, like stainless steel. So if you're using acid detergents, you should know that it can damage stainless steel, aluminum, and glass. So it depends on what the instruments that you are using there. You have to look at all these kind of detergents. So most of the time, your manager is going to do this, but then you're supposed to know because you're going to be a future manager and director. Okay.
Yes, because you've mentioned manager, let me also add this. Guys, so be mindful that when you start working, right, and you go to decontamination area, you see a lot of chemicals. Do not mix and match them. As you can see, we have different type of detergent for different purposes. For example, if you run out of detergent for your manual cleaning, ask your manager to tell you or to give you a good substitute for the detergent, the cleaning agent that you have run out. Of. Don't just go and pick any chemical because some of these chemicals are very acidic. If you use them wrongly, they can damage the instrument. So not only managers, where it also affects you is that you have to know which cleaning agent is used where. And when you are taking them, you can read the labels because today you have been exposed to the chemical composition and the term that is associated with this cleaning agent. Make sure that you know for anything that goes over 3, anything between 1 to 7.5 is acidic, and anything that's over 7.8, I believe, to 14 is very alkalinic, right? So that's what you need to know for now. Once you put those in your at the back of your brain, not only will you pass your exams, you will also be very informed when you start working. That's it.
All right, guys. That's a great advice for you. So detergents, because we know, as we said, they are different. When you see them, don't mix and match. Respect the grades that we've shown you. That's the reason why they are there. Don't mix them and match them. Use them accordingly as per the IFUs, and everything will be fine. If you don't understand anything, consult those that were there earlier or your manager, and then you'll be okay. Okay, so we have to be very careful with the detergents. When used properly, detergents penetrate and remove soil from instruments and keep soil in suspension. Okay? So it does not reattach to the instrument. So that is one good thing about detergents. So we've seen the levels of the pH. So we are not going to match them as we want. We got to follow the pH and look at them. There's a reason why they have all those pHs there. And as I told, the pHs are scales that we use to measure the alkalinity of it. Any questions? Common cleaning chemicals in decontamination, the pre-cleaning agents. Who is going to take this slide?
Common cleaning chemicals in decontamination. Pre-cleaning agents used immediately after procedures to prevent drying of blast and debris. Manual cleaning chemicals break soil bonds on instruments but do not kill microorganisms. Mechanical cleaning chemicals, low foaming detergent designed for the use of automated washer and ultrasonic cleaners. Key consideration, always follow the manufacturer's instruction for proper dilution and water temperature. Select detergent based on facility needs, water quality, and instrument materials. Regular testing and correct usage of cleaning agents are essential for effective decontamination.
Good job. So you see that this has to, it goes back to the manufacturer's instructions when you get there. Pre-cleaning agents used immediately after procedure. That's mostly they're gonna do it before the instruments gets to the decon. Manual cleaning, you're gonna be using it, which breaks the soil bounds on instruments. But do not kill microorganisms. Put that at the back of your head. And that is why it's not, I refuted the 100% answer that Obi gave me earlier. It's not. It's going to break the bonds on instruments, but do not kill the microorganisms. All right? Then it goes into the mechanical cleaning, where the chemicals, the low foaming detergents designed for use in these machines will clean it. Okay? So your considerations is that follow the manufacturer's instructions, the IF, we call it the IFUs, information for use. Select detergents based on facility needs. If you work with Marsana and they say, this is what we buy, your manager, your director brought that there. That's what you have to use because he knows why he got that for you. That's what they want over there. Okay, that's what suits their instruments. Regular testing and correct usage of clean agents are essential. You'll be told what to do, how to test it, and then you follow that. Okay, every facility has a different way of testing that. So if they tell you, oh, this is ours, and you test it this way, you have to follow it. Regular testing and correct usage. All right. Director, can I get the next slide? Types of soil and challenges in cleaning. This one is just two images that we see, right? What do you see in these images? Can someone just describe these images to me, especially the one without inscriptions? What is it?
Dirty instruments.
Dirty instruments.
Okay. Very rusty.
Yeah, you see. Some, it looks bloody in a way, it looks rusty, it's like just thrown over like that. It's like somebody just turned the instruments down, upside down, the tray upside down. We have to be careful how we work, okay? We don't have to be throwing things like that. We don't have to be jamming them like that. But we're going to see things like this. And look at the other side. It's supposed to show you open hinge instruments. Like, I don't know how to even describe that. We have instruments that have to be open. Some you have to dismantle it in a way so that the cylinder will be on the side and then the base will be on the side so that it can wash properly. Okay? So open hinge instruments and make certain all instruments will be contacted by the washer spray. How you're putting them in there, it's to make, it's like, let me see, like those from, we do grilling, right? Like summertime people do barbecue. See how they put their meat on the grill? Yes, so that every meat gets enough fire to actually cook it or roast it or make it fine as they want. That's what you should do. Every instrument that you put in there should be exposed to the spray house. All right? The washer spray has to be able to spray every instrument in there. Are we all good with that?
Yes.
Okay, so let's go to the next slide. Okay, so what we see here, who can read this? Someone should take this up. we spoke about the enzyme products, right? They are used in the decontamination process. So we don't need to spend too much time on this. Okay, chemicals are different. So you have to read the labels as advised by a director. Don't just use it. Read the labels. If you don't understand anything, contact your manager or your co-workers, they'll show you. If they're not able to tell you the right thing, go to your manager. Okay, detergents commonly used chemicals in cleaning. That's just a simple definition for detergents. And then review of common chemicals. As we said, these are qualities of the detergents that we just spoke of. So when you go to some places, you have the green, you see that green or gray box? It tells you of the emulsifiers, the surfactants, and then the chelating agents, which you need to write. I don't think you need it right now, but then it should tell you something about these detergents. Any ingredients used to bind together substances that normally do not combine, such as oil and water. That's an emulsifier. Okay? And then we have the surfactants, the substance that lowers the surface tension of the water and increases the solubility of organic compounds. And then we have the chelating agents, which are chemicals that hold hard water materials in solution and prevent the detergents from reacting with the material. So you see, these are all boosters to the detergent. It helps the detergent to do the work that we want them to do. All right? So the images that you see, I'm not relying on the images that much, but the key here is chemicals are different. So always read the labels. Director, can I get the next slide? So steps in the process of decontamination, the point of use. Who is going to take this slide for me? Who's going to take this slide?
Let me do that, sir.
Okay.
Point of use. The process of decontamination begins with the end user.
Okay.
At the point of use, our staffs should take the time to ensure that the initial steps of decontamination are performed.
Yeah, the OR, the OR up there, operation room.
All right. Yeah.
Okay. So the OR staff, which is normally the nurses and the surgical technicians and stuff, they should take the time to ensure that the initial steps of decontamination are performed. As we said, decontamination starts long before it even gets to us at the decon. They're supposed to do that. Okay, they have to start the process, and then they bring it to us over there. All right. Well, the second one says what?
The soil receiving collection of used items.
So we will be collecting the used items, which is the instrument that's going to come after they have done they've started the process of cleaning, which is a pre-cleaning. They've done it. Then we will be receiving those instruments at the decontamination area. Director, can I get the next slide? Okay, so use the appropriately sized brush, which we spoke about already. So we're not going to waste time on this. If the size is too small, it's not good. Too big, not good. All right, you have series of sizes of brushes. Make good use of the appropriate sizes. And then we go to cleaning orthopedic instruments. Who is going to take that for me?
I'll read it.
Okay.
Cleaning orthopedic instruments. Importance of initial cleaning. Orthopedic instruments can conceal bone and bioburden. Initial cleaning with brisk brushes is essential. Thorough inspection. Check all crevices carefully. Blood and bone may be in other areas of the instrument. Focus on areas besides the biting or cutting section.
All righty. Thank you so much. You see, orthopedic instruments are more like for the what is it, like injuries. They're more like for the musculoskeletal injuries and stuff. That's what we call the orthopedic instruments. And most of them are like osteotomes. You know, it may sound Greek to you now because you've not seen the instrument. Osteotomes are like little chisels that that carpenters use. They are slight, long ones, like the osteotomes, like heavy metal chisels. The randules, the retractors, the implants, the drills. We have a lot of drills at the hospital. Those are the orthopedic instruments. And as she told you, they are difficult to clean. Okay? They can conceal bone and bioburden. You'll be surprised that that little round jaw you open and you see fragments of bone in it. And when you brush it, it doesn't even go easily. So remember that if you have to deal with cleaning orthopedic instruments, be extra careful. The initial cleaning is so important to get rid of all those things. Initial cleaning with brisk brushes is essential. And then thorough inspection when it comes to you, look for these bone fragments. Okay, check all crevices carefully. Blood and bone may be in other areas of the instrument. Okay, focus on areas beside the biting side, where the rangeau, the teeth, where you use to bite. Don't just focus on that. The pivot points, the lock, the box locks, they could be there. Okay, so you have to take good care of that. And I've given you examples of it when you hear the names when you get to the field. Okay, so those are orthopedic instruments. Director, can I get the next slide? Okay, the task precautions in the decontamination area. Who's going to take this for me? Someone should take that. Who's going to read that for us? Anyone? Is Joseph around? Is Obin there?
Task precaution in decontamination area. Risk of task in eye surgery caused by contaminants entering the eye.
Okay.
Result from inadequate instrument processing. Reduces task risk in decontamination area. Follow manufacturer IFU for cleaning. Prevent biofilm formation on instruments. Use recommended enzymes and detergents. Keep cleaning tools clean. Flush lumen thoroughly. Rinse copiously with recommended water. Additional precautions. Follow facility-specific protocols.
Good job. Thank you so much. You know that following the facility-specific protocols is very important. That's like the culture of that hospital, the culture of the facility that you're working in. Follow that facility-specific protocols. If you don't remember protocols, ask yourself, what is the culture here? Follow that culture there, okay? That's additional precaution. But then the task is thoracic anterior segment syndrome, okay? So now we're talking of ophthalmic instruments, which are used to diagnose and treat eye and manage eye-related injuries or disorders, all right, or eye diseases. That's when we use ophthalmic instruments. So when you're using that, the risk of this thoracic anterior segment syndrome is caused by contaminants entering the eye. That is what it's caused. What causes it. It's very prevalent, and it appears a lot of times in our book. It results from inadequate instrument processing, which means it's our fault, right? It's our fault. We didn't process it right. Okay. So to reduce that, we have to follow the IFU, which I told you, the information for use, the manufacturer's recommended use. Use that. Follow that to clean it. Prevent biofilm formation. Wash it as soon as it gets there. Don't let it dry out to the point that it's going to form the biofilm. Biofilms are stubborn. They're notorious. It's going to give you a hard time. So why wait? Get it out of there. Okay? So there's no biofilm formed on there. Use recommended enzymes and detergents. Looking at the pH, it's going to be provided there for you. Keep cleaning tools clean and flush lumens thoroughly. Make sure you pumping water through these lumens, through these channels, clean to get it at the most that you can, and with the brushes, and then rinse copiously with recommended water. We've told you about the water and the contaminants and everything. You gotta make good work of that. Okay. Any question here? All right. Director, gotta get the next slide. I think we're doing good so far. Okay, so I've told you about this ophthalmic instrument, all right, for eye diagnosis. Okay, so importance of cleaning protocols. Cleaning protocols are like the rituals, the culture that we use to do this. Due to increasing incidence of thoracic anterior segment syndrome, which is the TAS, follow manufacturer instructions, as I said, and then follow the facility recommendations. Okay, have sufficient instrumentation. allow adequate time for processing between patients. The have sufficient instrumentation is going to be on you when you become a manager or director. Make sure your workers have enough instrumentation, okay? Don't let them run out and say, oh, you got to do quick turn here. Okay, facility recommendations. So change the culture there, all right? Director, can I get the next slide? Any questions so far? Okay, so we see a lot of instruments. We have the orthopedic, the neurological surgery instruments, depending on which facility you go to, all right? Not all facilities use all these. Every facility has its specialty. So based on that, you go to some facilities like special surgery, you're gonna see instruments like access, big ones, huge ones. You go to another instrument like NYE, you see eye instruments, tiny ones that you need microscopes to be checking them, okay? So you're gonna be seeing those things. So this is orthopedic and neurological one. External preparation and inspection. Who is gonna take that? Somebody should take that so we can go quick. It's 5:12. We have at most like 30 minutes to do this and then have some time to ask questions. We are almost done. We are almost done. We did very well. You guys did very, very, very well.
I'll read it.
Yeah, let's go.
Cleaning orthopedic and neurologic surgery instrument. Extended preparation and inspection. Orthopedic and neurologic surgery instruments require thorough preparation. Includes joint replacement, cutting guides, rasp, manus, and bronchs.
Yeah.
Challenges in cleaning. Instrument hide blood, bone and tissue. Sorry. Occurs even with best point of use care in the OR. Cleaning methods. Brushes and extensive hand detailing needed. Pre-soaking with enzymatic detergent help remove bioburden. Special washer racks. Designed by some washer manufacturers. Hold and brush out these devices.
Good job. So we see that it's challenging because these instruments are instruments that are used for delicate surgeries. They involve cutting guides, rasps, madness, a lot of things. So they come with blood on them, very bloody, bone fragments and tissue. So even the best pre-cleaner that will do is still going to bring it with bioburden. So don't expect that it's going to come crisp, clean from the pre-cleaning. No. To get that out of your mind. It's not going to come like that. Expect the worst. So when it comes there, just do what you are supposed to do. It's challenging, okay? But use the methods, use the brushes, do extensive hand detailing needed to do it. Pre-soak it. With the enzymatic detergents, remember the enzymes break the bioburdens down. So it's a helper. It's going to help you. So soak it. Make sure you have the appropriate quantity in the water, the 5-gallon limit, and then the appropriate quantity of 1.25 ounces in there. You are good. Pre-soak it. Let the detergents do some work for you. The enzymes do some work for you, and then take your time, one by one. Make sure you touch every instrument and get them clean. All right. Special washer racks are used for this kind of instrument because I told you some are so big they need a special rack. And I told you at my other side, some are so tiny, they need special basins, baskets to put them in to wash. Okay, hold and brush out these devices. All righty, they must be clean. Can I get the next slide, Director? So laparoscopic and robotic instruments. You know, right now we're high tech and information technology is going so fast and we are always abreast with it. Even if you're behind, it's just slide. Because the more technology we get, the easier the work gets for the doctors, but then the difficult it gets for cleaning. Do we all believe that? We're getting more complicated instruments, which needs complicated cleaning. So the more easier work they are getting, we are getting more work that needs more time and more care. All right. So now we're getting these laparoscopic instruments. We have some that we have jackets that we have to take the jackets off the instruments. Imagine that. So if it's 100 and there are some instruments that are 160, like 113 pieces in there. If these 113 pieces have jackets, and you take them off, you have 200 and how many? 226 pieces. Rinse through them all, use brushes to clean them. Make sure, like the biopsy faucet, make sure the tip is clean, and you have to do all that. So it's getting easier for them to do their work, but it's getting more difficult for us to do our work. But then we have to do it because we have to pay special attention to detail to make sure these laparoscopic instruments and robotic arms are good enough to work and get us the patient care that we want. All right. So it's challenging, but then we have to do it. All right. They're difficult and time consuming, but we have to do it. The importance of following the manufacturer instruction cannot be overemphasized here. If you don't follow that, like the jacket that I'm telling you, the same instrument has a jacket, it has a ratchet. You have to clean all the crevices. Take the jacket off, and then afterwards you have to, and then we disassemble the ratchet. Then after washing, you have to reassemble all that. So that's where it's time consuming, but then it has to come out clean. All right. So you need the properly sized brushes, as we said earlier, and you have to be flashing them. Flashing instructions as per the manufacturer's instruction, as per the information for use, the IFU. Okay. If you don't clean it properly, what happens? Instruments can be damaged by excessive air and water pressure. Because you think that let me do it this way, it's going to be quicker. Then you end up damaging them. They cannot do the work that they're supposed to do. You're going to be at risk. The patient is going to be at risk. Work is not going to go on as supposed to go. And this thing costs a lot. I don't want director to even come in here to give you a picture of it. They cost crazily expensive money to get them. All right. Okay. Then this one says mechanical cleaning equipment. Special baskets are required for these laparoscopic instruments, because the regular baskets at times cannot take them. Like our end, we have longer baskets, thank God. So at times when we have this, we have to put their containers on the side and then put this instruments in longer baskets, put in the washer. Some places, if your washer is not that long to contain it, it means you have to find another way to wash it to make sure it goes into the automated machine. All right. So it needs special attention, which is the key to your job. Okay. All right. Can I get the next slide? So cleaning flexible and rigid endoscopes. I've told you about endoscopes that are more like cameras and stuff, but they are not like the regular street cameras that we use. Some are like stringed cameras. Some are like robotic arms. And then they connect them to the tower, which is the video tower you see in the hospitals. You connect it to it and use it on these instruments to on patients to diagnose and look at inside of the patients, try to cure or do the procedures, try to get them the right spots by minimizing the cuts and stuff. So these are flexible endoscope. We have rigid ones, which are like rigid, hard ones, and we have flexible ones, which are like strings. Okay, and that's what we use. So these are the types, the flexible ones and the rigid ones, the flexible endoscopes and the rigid ones. And then we have the special cleaning concerns. They require unique cleaning requirements for these endoscopes. I told you some come with ready-made sponges with special detergents on them that we use to clean them. If you don't have it, your director or your manager is going to tell you how to do it. They'll show you what we use in doing. Most of the time, some will be hand washed, because most of these endoscopes have to be cleaned specially. And those cameras that come with them, some of them don't even go into water. So we have to pay attention to all that. Okay? That's the importance of thorough decontamination. You have to make sure they are clean, but then they have to be clean in a special way. Further information will be discussed in another chapter, but as of now, this is what I can tell you about the flexible and the rigid endoscopes. So now cleaning new or repaired instruments. Who is going to take this? We are almost there. Don't worry, we're good. Cleaning new or repaired instruments. If you are at the SPD and you send instruments for repairs and they come in, what are you going to do? What will you do? Tell us. Who is going to tell us? You are already graduated and you are working. What will you do if they bring instruments from the repair shop? Anyone?
I mean, I think the first thing is you need to clean it.
Good job. The first step is to clean it. That's our anthem. It has to clean. You don't know what they did to it at the repair shop. You don't know who touched it and where it went. It was exposed to so many things. So as number one rule, consider it dirty when it comes in there. Okay? So it goes straight to where? The decon. You register it in the decon, you rinse it off, flush the lumens and all the suctions in there, and then put it in the washer before it goes back to the clean side. Are we all okay with that? Slide is telling you all new or repaired instruments must be cleaned before disinfection or sterilization. Instruments tagged for repair must still be cleaned and decontaminated. When instruments are returned from repair, they must be considered contaminated. Are we okay? They must be cleaned, decontaminated, and inspected before being returned to their respective sets. All right? Surface contaminants. Instruments may appear clean, but have fine metal dust, oils, and other debris on them. All right? Debris come from the manufacturing process. So if it's new, it still needs to clean, right or wrong?
Right.
Because remember, we want sterility, not just cleanliness. Okay? All right, that's the next slide. Wipe down hoses and
Mr. Josh.
Yes, sir.
This is Bosco. Can I just say something before you go to the next slide?
Okay.
Okay, so let me ask the class the question. If you bought a cooking utensils from the shop, do you just cut your meat and put it there and go straight away to cook, or you wash your cooking utensil?
Oh, we wash it.
You wash it.
All right, fantastic. That's why you need, when new instruments are bought, you still have to decontaminate them. First, they are coming from outside. Two, when you open them, the hinge side, you will see some oily substances. So you need to take off those oily substances so that they look clean before you use them. Thank you so much.
Thank you, Professor John. So that is the good thing that we know that new things come in. We don't have to accept them, especially the decon. If we don't accept them wholeheartedly in the decon, it's a no-no. You have to go there and wash and go through the process, okay? Go through our culture. All right. So now it says wipe down hoses and cords carefully. I've told you our cameras have cords and hoses that come with our instruments. You see the image up there, the black hose? The color makes it difficult to detect any dirty stuff on it. You see that? So you have to wipe this hose carefully. Cleaning procedure, use approved solution and a clean soft cloth. Pay special attention to the ends to avoid water damage. I've told you these instruments are special, okay? So please use approved solution and then pay special attention to the ends to avoid water damage. Instrument characteristics. Dark color makes it difficult to see dried blood. Meticulous attention requires for cleaning. You have to make sure you pay special attention to these things. You cannot overlook anything. Manufacturer guidelines, that's our number one thing. Do not rinse under running water unless approved. Because like we had one probe that we used after our end, the Doppler probe. If you rinse it under water, it's going to take you like 2 hours to get it dry. Even though it's not going to break down, it's going to take you at least 2 hours to get it dry for processing. Okay, so if you look at that, the IFU for that instrument definitely is going to tell you that no, don't rinse it under running water. And if it happens that way, it may also break, because the more water goes in, it's going to break. It's against the IFU. All right. There are some instruments that when I started at first, we had certain instruments that kept breaking down. And later on, the director at that time came and said, "Hey, guys, this instrument keeps breaking down. What is happening?" And those that I even met didn't know that that thing didn't need so much water. So it looks like they were also already washing it in the water like that. So he said, no more. And since that time, it didn't happen again. Even though the same ones were still in the system, it didn't happen again. Because we realized that, oh, the IFU went against the IFU. So if you don't have the IFU, talk to your manager. If you're not sure, you want to see the IFU, talk to your manager. He'll definitely get it. He or she will definitely get it for you, so that you can be sure you're doing the right thing. All right? Because I have managers here that can even tell you, but right now we're out of time. So you have the manufacturer's guidelines, and then inspection and repair. Check for nicks, breaks, and tears. Be careful. Last time we had a very tiny scissors that we call the Westcott. it came with a broken tip. Very, very tiny. But we had to take it off. If you look with your eyes, you're going to say it's good. You go and put it in the magnifier, you see that, oh, it's a brick over there. All right. So inspection and repair, please. If it's repairable, put it in the bin for repairs. If it's not, it has to go in the shops and put it away. Okay. Mark damaged items for repair before sending to assembly. Don't let them go and be assembled. Now, can I get the next cleaning instrument containers and basins? We have bins that come with the instruments, and we have the canisters, the one that we sterilize the instruments in. They're all going to come to the decon because everything has to pass through the decon before it goes to the clean side. Check handles, locking mechanisms, and container rims for cracks and missing components. At times, it will go in with a handle and it will come without a handle. At times, it will go with the lid, it will come without the lid. At times, the instrument basket will come with the instruments, the canister is not going to come. Look out for all that, okay? So that you can ask for it and track the room quickly and then go get it. Your manager can get it, or any worker that is out in the cleaning side can help you get it. Damage handling. Mark damaged containers for repair or removal from service. Send marked containers to the assembly area. Any questions as of now? All right, so avoid damage to critical parts. Access doors and hatches. The doors are always vulnerable. Check them. Must be open to clean intricate parts. Extreme care needed to avoid damage. Cleaning materials, soft materials, and applicators recommended. Don't go and use any bristle, any hard, abrasive bristles on the instruments. They will not even be available at the decon anyway. But don't go and get your own brushes and stuff to the decon to clean because you say this one is not cleaning right. Those there are the appropriate and recommended ones. Use those ones. They must be soft materials and applicators that are recommended. Cleaning around switches and cords. Thorough cleaning required. Ensure cloth is not overly wet. All right. And the next slide, Director. Quality testing. You know, we're all about quality, right? Devices to inspect instruments for cleaning. You have to make sure everything is clean. It's about cleanliness. Various devices and methods, including swabbing, are used to inspect instruments for cleanliness and detect residual soil. Like I told you about the fluorescent testing. You look at it through the fluorescent light and you see that, whoa, this thing was washed, but it still has protein on it. You need to check all that when the need arises to make sure that it's good. It's residual soil has been taken off. Decontamination. That's the definition of the decontamination. Who's going to read it for us? Because we all have to know this. Decontamination. Who's going to read it? Under. It's under there? Okay, yeah. Tafik, let's go.
I'm here.
Okay, under, let's go. Decontamination.
Devices to inspect instruments for cleanliness.
Yeah.
Various devices and methods, including swabbing, are used to inspect instruments for cleanliness and detect residual soil.
Good. Yes, the next one.
Decontamination. This process uses physical and chemical methods to remove or inactivate bloodborne pathogens, making items safe to handle and reducing bioburden for further processing. Some instruments require additional microbiocidal treatment.
Good one. Microbiocidal. Killing the microorganisms, okay? So it's microbiocidal treatment to kill the microorganisms on there. Good job. So let's go. Director, can I get the next slide? Importance of proper transportation. Who can take that? We're almost done.
Yeah, I'll continue.
Okay, good one.
Importance of proper transportation reduces risk of cross-contamination, prevents exposure to bloodborne pathogens. Location of the contamination area, often near the operation room, OR. Majority of contaminant instruments are generated in the OR.
Good one. So we say we did this already. This is more like refreshing you. The location of the decon area is often near the OR. All right. And we said it's cost effective to do that because it costs you less to be transporting goods back and forth, instruments back and forth. Majority of contaminated instruments come from the OR. So it's good to locate it near the OR, right? All right. Director, the next slide. So there's a conclusion. Who's going to conclude for us? Is Obin there? Obin? Joseph? Yeah,
Yeah,
can you
let me
conclude
take
for
it.
us?
Okay.
Okay. Who's taking it under?
Conclusion. Cleaning is a critical multi-step process essential for the success of disinfection and sterilization. CS technician must thoroughly understand and consistently follow proper cleaning procedures to ensure patient and healthcare worker safety.
Good job. And I want you to read it over again. And when you get to the CS technicians, you have to say, we must thoroughly understand it.
Yeah, we
Uh-huh.
must thoroughly understand and consistently follow proper cleaning procedures to ensure patient and healthcare worker safety.
Amen. That's a good job, Handa. Then go to the next slide. Do you have any more slides? No. Okay. Ramadan Mubarak to all Muslims. See you tomorrow, same time, okay?
Thank you.
Any questions before we leave?
Thank you, Professor.
Thank you.
Thank you so
No,
much.
no questions.
Thank you.
You guys are marvelous
Thank
today.
you.
You know, the Muslims are rushing. They were
Welcome.
like, no question, leave us
No
alone.
question.
Bye.
Well, I no question. Let us go.
Bye.
All righty.
All right, guys, we'll see you tomorrow.
See
Have
you.
the
See you
same
guys
books.
tomorrow.
See you.
All right. Goodbye,
Bye.
No.
guys.
All right.